So, good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to speak on momentum and discuss a basic worksheet on momentum. So, let's begin with things. So, here is the basic worksheet on linear momentum. So, let's start with first the definition of linear momentum. So, linear momentum is defined as mass into velocity, where p is the linear momentum, m is the mass, and v is the velocity. So, we can say that linear momentum of a body is proportional to the velocity, or the direction of velocity and linear momentum is same. Next is, if we think in terms of magnitude, we can say that p is equal to mv, where p is the magnitude of momentum. Sorry, here it is magnitude of momentum, m is the mass, and v is the speed. Next is dimension of momentum, it is m1 l1 t minus 1. Next is SI unit of momentum, it is kg meter per second or Newton second, both are the same thing. Next is CGS unit of momentum, it is gram centimeter second minus 1 or dyne second. Next is, if we draw a graph between p and m for constant speed, we can see that p is proportional to m. So graph will be a straight line, and tan theta is equal to p by m, which is equal to v. Next to now we have three graphs corresponding to three different angles, out of which theta 3 greater than theta 2 greater than theta 1. So tan theta 3 will be greater than tan theta 2 will be greater than tan theta 1. So v3 will be greater than v2 greater than v1. Next is, if we draw graph between p and speed for constant mass, we can say that p is proportional to v. So graph is gonna be a straight line. And if we find tan theta is equal to p by v, which is equal to m. Next, if we have three different graphs corresponding to three different m, then we can say that tan theta is equal to m. So from the graph we can see that theta 3 greater than theta 2 greater than theta 1. So tan theta 3 is greater than tan theta 2 greater than tan theta 1. So m3 greater than m2 greater than m1. That we can analyze. Next is relation between momentum and kinetic energy. This is p is equal to root 2 km. Next is, if we draw a graph between p and k, so we can see that p is proportional to root k, so graph will be a parabola turning toward k axis. Next is, if we have three different graphs corresponding to graph 1, 2, 3. So if we draw line perpendicular to k, that makes sure k is same for all the three. So we can say p proportional to root m. So as you can see from the graph that p1 here is greater than p2, and it is still greater than p3. So p1 is greater than p2 is greater than p3, which implies m1 is greater than m2 greater than m3. Next is, if we are being given a graph of p versus root k, so it is proportional to x, so graph will be a straight line. If we find tan theta, that is p by root k, so it is root 2m. Now if we are given three graphs based on different cases, so we can see from the graphs that theta 3 is greater than theta 2 is greater than theta 1. That means m3 greater than m2 greater than m1. This inference we can draw from analyzing the graphs. Next is, if we draw graph between p and root m, it's gonna be a straight line for constant kinetic energy. Next is, if we draw graph between p and m, it's gonna be a parabola turning toward the m axis. Next is, if there are three graphs possible corresponding to a given m, just drop a line perpendicular to m. That makes sure m is constant for all. So we can see that over here that p1 is greater than p2 greater than p3. That means k1 is greater than k2 greater than k3. Last is dimensions of k, it is m1 l2 t minus 2. So this is a basic worksheet on linear momentum, which is just aspiring to make sure that you know the key terms, the basic concepts, the graphical variations, and different manipulations. I shall be uploading next level worksheets soon, so stay connected, tune up, and drop your comments in the comment section of YouTube videos. Thank you and have a nice day.